is Form 3 Mathematics, Topic 2, Approximation and Errors. Well, today we are at Lesson 4 and we are looking at propagation of errors still. Previously we looked at propagation of errors in products and summations. Today we look at quotients and differences, and we have a question to guide us. We are at question 5. Calculate the percentage error in the following. So the first one is a difference at A. So 5.4 minus 2.35. So the solution to this, first of all, we have to determine the actual value, that is the actual difference, which is 5.4 minus 2.35, just from the values provided there, and that should give us 3.05. Next, because we are interested in getting the percentage error, the procedure still remains the same. So next we get the absolute error, which is obtained by simply determining the absolute value of the maximum difference minus the minimum difference, all divided by 2. So for us to determine the maximum difference, first of all, we know that maximum difference is obtained by simply having the maximum value of 5.4 minus the minimum value of 2.35, and later on we'll also work out the minimum difference, which will be obtained as minimum value of 5.4 minus maximum value of 2.35. So next, the maximum value would therefore be obtained by simply having the maximum value of 5.4 minus the minimum value of 2.35. Like always, first we need to determine the limits of 5.4. So 5.4 ranges from 5.35 to 5.45. We also have for 2.35, we have 2.345 up to 2.355, so that the maximum difference will be the maximum value of 5.4, which is 5.45, minus the minimum value of 2.35, which is 2.345. So this should give us, when we work out that, we are going to get 3.105. Next, we also need the minimum difference, which now is the minimum minus the maximum. So the minimum value of 5.4, which is 5.35, minus the maximum value of 2.35, that is 2.355. And when you work out that, we should be getting 2.995. So that the next step, the absolute error becomes the absolute value of the difference between 3.105 and 2.995 divided by 2. So that gives us, so that implies that the absolute error is 0.055, and then from there we can now get the percentage error, and the percentage error now is the relative error, which is 0.055 over the actual difference, which we found to be 3.05 times 100, and finally we get the result as 1.803%. So for part B, we have a quotient that is 2.7 divided by 5.4. So we are going to determine the percentage error in this working. So the solution is, first of all, we need to determine the limits. So for 2.7, we realize it lies between 2.65 and 2.75, and again 5.4 lies between 5.35 and 5.45. So with this, we can now determine the actual quotient, and the actual quotient is just 2.7 over 5.4, and that should give us 0.5. Like before, we are going to determine the absolute error first, or which in this case will be the maximum quotient minus minimum quotient all over 2, and for that reason maximum quotient is obtained as maximum of the numerator over the minimum value of the denominator. So that means for maximum quotient we are going to have the maximum of the numerator, which is 2.75, over the minimum of the denominator, which is 5.35. When this is worked out, we should be getting 0.5140. Next, we get the minimum quotient, and the minimum quotient is minimum value of the numerator over the maximum value of the denominator. And for this case, we have on the numerator 2.65, that is the minimum value of the numerator, all over maximum on the denominator, which is 5.45 right there. So when this is worked out, we should be getting 0.4862. From there, we can now determine the absolute error, and that will be the absolute value of the difference between 0.5140 and 0.4862, all divided by 2. So that will give us 0.0139. So from there we can now work out the percentage error, and the percentage error, as always, is relative error times 100, and the relative error will be absolute error, which is 0.0139, all over the actual quotient, and the actual quotient we got as 0.5, and then we multiply by 100. So the result we are going to get here is 2.78%. So next is a bonus. So as a bonus, if you have a quotient or a product, for example 2.7 divided by 5.4, or if you have 2.7 times 5.4, then the percentage error is obtained by simply having the relative error times 100, of which the point of interest is on the relative error. So the relative error in this case will be the sum of the relative errors for the individual values we have here. So we'll have the relative error for 2.7. So for 2.7, the absolute error is 0.05. Similarly, for 5.4, the absolute error is 0.05. So we will have the relative error for 2.7, which is 0.05 all over 2.7, plus the relative error for 5.4, which is 0.05 over 5.4. Now this should represent the relative error in the quotient, and the same should also apply for the product. So once we've gotten this, next we multiply by 100, and the result should remain the same. We should have 2.78%. Well, that's it for that. Finally, we have an exercise for you, and the exercise is calculate the percentage error in the following. So we have a difference and a fraction. So the fraction here is a quotient, and the difference here, this is the difference. So apply the same procedure as we've done before to determine the percentage error. Otherwise, thanks for your patience. See you next time.